Good afternoon, fellow viewers. Welcome back to Easy Mathematics. We thank God today is Friday. Today we want to still continue on the decimals, and under decimals today we are coming to talk about standard form. Already we wanted to talk about approximations in decimals, that is rounding of decimals to a given place and rounding of decimals to a significant figures. But we've already talked about the approximation. So in our previous videos, we have how to round decimals to the nearest tenths, hundreds, thousands, and also how to round a number to a given significant figure. Today we want to talk about standard form. A standard form, that we say, what makes a number to be a standard form? Now, a standard form or a standard number is given as a times 10 raised to the power n. A times 10 raised to the power n shows that a number is in a standard form. One will ask, what is a and what is n? A is equal to all the positive numbers from 1 to 9. All the numbers from 1 to 9, or between 1 and 10. So A represents all positive integers from 1 to 9. So if I have 1, 2, 3, 4 up to 9, that number qualifies to be a standard form. And n also represents the number or represent the powers of a certain number. So n also refers to number. So an example of a standard form is, let's say we have 2.1 times 10 raised to the power 2. This is a standard number. N is an integer. It can be negative, it can be positive. Now this number is in a standard form because 2.1, I can get 2.1 in this range. 2, I can locate 2 in 1 to 9. So this number is a standard number or a standard form. If I have 8.41 times 10 raised to the power negative 4. This is also a standard form. It's in standard form because 8.41, I can get this number within the ranges 1 to 9. Because before you get to 8, if you want to go to 9, you get to 8.41. So if you look at the number that comes up before the decimal point, if that number can be located from 1 to 9, we say that number is in standard form. When we are having times 10 raised to the power n. Good. How can I know that a number is not in a standard form? A number that is not in standard form, we are going to get, let's say you have 25.1 times 10 raised to the power 5. This 25.1, 25, there's no way we can get 25 from 1 to 9. So because we cannot get 25 from 1 to 9, we cannot get 25. We say that this number is not in standard form because 25 is not in this range. But if I'm having 2.51, it is in standard form because I can get the 2 within the range. The same thing happens if you have 84.1 times 10 raised to the power negative 10. Although we have times 10 raised to the power, this 84, we can't locate 84 in these numbers from 1 to 9. Because we can't get it, we would therefore say that 84.1 times 10 raised to the power negative 4 is not is not in a standard form. So I can get 1 point blah 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 times 10 raised to the power 2.3 point times 10 if the number that comes before the decimal point cannot be located from 1 to 9, we say that number is not in a standard form. Good. So let's look at how to change or changing numbers into standard form. Now we know what shows that a number is in a standard form. If you have the number that can be located from 1 to 9, we will say that number is in a standard form. So 2 points times, you say it is in standard form. So let's write this number in a standard form. How can we therefore write this number in a standard form? Now this number is 41,640. It is a whole number. Since this number is a whole number, how can I change it into standard form? To change a whole number into standard form, we have to get the number that falls within this range, 1 to 9. So if I move from this place to here, this number, I will locate them within that range. So we are going to move from this position. 1. Count the number of times that you move. 2. This number, I can't locate them. So I'll move again. 3. 4. So I can pause here because 4, I can get 4 within this range, 1 to 9. So this in standard form is going to give me 4 points. Now this 4, I can locate 4 in 1 to 9. So I'm going to get 4.1640 times 10 raised to the power. How many times did we move? We moved 1, 2, 3, 4 times. And you can see that when we were moving, we moved to this direction. So because we moved to this direction, which is to the left, the power here becomes positive, so 4. So changing this in standard form gave us 4.1640 times 10 raised to the power 4. Let's come to number 2. We are changing it into standard form. So what do we have here? We come to this direction, move from here, because there is no decimal point here, we start from this side and move to get number from within that range. So 1, 2, 3. Now I'm having 2.000 times 10 raised to the power. How many times did I move? 1, 2, 3. I moved 3 times. And the movement was done this way, to the left. So if the movement was done this way, the power of 10 becomes positive. Now when you look at the number 3, we have a decimal point here, which is 349.84. Now this number, we cannot locate 349 in the numbers 1 to 9. So we have to therefore change this number in a standard form. By this time, because there is a point here, we are going to begin or start from the point. So we are going to start from here. 1, 2. Now I have 3 points. I've been able to move the decimal point, which was after the 9, to this place. So I'm going to get 3.4984 times 10 raised to the power. How many times did we move? We moved 1, 2. So because the movement was done towards this direction, to the left, the power of 10 becomes positive. We moved 2 times. So this in standard form is going to give us this. The same thing when it comes here. Look at where the point is. The point is located here. So let's see the number of times we can move to get the number within that range. So we can move 1, 2, 3. So changing this in standard form is going to give me 3.2017 times 10 raised to the power. We moved 3 times. And the power of n becomes positive because the movement was done towards our left. Now let's look at the number 5. The number 5, it looks like the number is in decimals. So therefore, we are going to change this one into standard form. When you look at where this decimal point is, I can't move to the left because there are no numbers here. So therefore, I'll move to my right. So if I move 1, 0, 0, it is not within that range. 2, 0, 0, 0, it is not in the range. So 1. Now I'm going to write 1 point, and this 1 point, or I'm going to write 1. This 1.0, I can locate 1 in this range. So this will give me 1.0 times 10 raised to the power 1, 2, 3. 3. But this time, because we move to our right, the power of n becomes negative. Remember, I told you that n, where n is an integer, integers are positive or negative. So here, because we move to our right, the power of 3 becomes n. But if you move to your left, the power of 3 becomes positive. The same thing happens to this one. I can move to this direction, so therefore I'll move here. You can't move again because 75 is not in the range. So what do? I'm going to write this as 7.543 times 10 raised to the power 1. So negative 1. Why negative 1? Because I moved to the right. So if you move towards your right, the power of n becomes negative. But if you move towards your left, the power of 10 becomes positive. Good. This one too, we have to change this in standard form. So I want to move. I can't move this way because there are no numbers here. So moving will give me 1, 2, 3, 4, 5. This is going to give me 2.736 times 10 raised to the power. I move 1, 2, 3, 4, 5 times. So because I move to my right, the power of 10 becomes negative 5. So this in standard form is 2.736 times 10 raised to the power negative 5. The same thing we are going to do here. So when you look at this, if I'm to change this in standard form, I'm going to get 5.72 times 10 raised to the power negative 3. 1, 2, 3. So you are going to get negative 3 as your answer. So this is how we change numbers into standard form. Now let's look at the opposite of this, where we will change a standard form into its original number. So changing numbers in standard form to its original number. Now when it comes to this one, there is a slight change. When you look at the power of 10 here, the power of 10 is positive. So I have 1, 5, 4. The number that I'm having here, I'm having 1.54. I'm to change this number into standard form, into its original number. Now when you come here, the power of 10 here is 7, and it is positive. Because it is positive, I have to move to my right. That is if you are changing from standard form to its original number. So look at where the decimal point is. It is here. And the power of 10 is positive. Because it is positive, I will move to my right. By here, you will move to your left if you are changing it into standard form. And if you move to your left, the power is positive. But if it is in standard form and you are changing it into its original number, it becomes the opposite of it. So I'm going to move to my right 7 times because the power of 10 is 7. So from the decimal point, 1, 2, 3, 4, 5, 6, 7. Now, the places where there are no numbers there, we are going to replace them with zeros. So this in its original number is 1, 5, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is 15,400,000. This in its original number. How did we do it? Locate the decimal point and check the power of 10. The power of 10, is it negative or positive? If it is negative, if it is positive, move to your right. So when you come to the number 2, the power of 10 here is positive 3. So because it is positive, I will move to my right. So what do I have here? I'm having 3.145. Locate the decimal point. The power of 10 is 3, which is positive. So I'll move to my right. How many times? 3 times. So moving will give me 1, 2, 3. Now the point will come behind the 5, which is going to give me 3145. So this in its original number is this. And if you use this approach to change this into standard form, you end up getting this. So if you are changing in standard form to its original number, consider the power of n. If it is positive, move to your right. Good. Now let's come to this side. What do we have here? We have 5.415. And we are changing this into its original number. Changing this in its original number, consider the power of 10. The power of 10 is 4, and therefore it is positive. So because it is positive, I will move to my right. So moving to your right 4 times is going to give us 1, 2, 3, 4. Because there is no number here, we are going to replace it with 0. So the original number for this standard number is 54150, which is 54,150. And if you change this into standard form, it's going to be 1, 2, 3, 4. You are going to get the same thing here. So if the power of 10 is positive, to change it into its original number, move to your right. That is, if you are changing from standard form to original number. Now what will you do if the power of 10 is negative? If the power of 10 is negative here, we are going to move to the left. And the number of times depends on the power of 10. Now what do we have here? We have 6.23 here. This is what we are having. And this is times 10 raised to the power negative 5. Because the power is negative, we'll move to the left. How many times? 5 times. So let's move to the left and see. We are going to get from the decimal point. The power is negative, so move to your left 5 times. 1, 2, 3, 4, 5. Here. So the point has come here. So because there are no numbers here, we are going to replace them with zeros. 0, 0, 0. Now this point has moved to this place. So I'm going to get point 1, 2, 3, 4. 4 zeros, 6, 2, 3. Then because there is no number in front of the point, we just bring 0, which will give us 0.0000623. And if you use what we did here to change this into standard form, you move to the right. That is if you are changing decimals like this into standard form. So if the power of 10 is negative, you have to move to your left. Let's look at the number 5. We have 6.32. We are changing this into its original number. Consider the power of 10. The power of 10 is negative 3. So because it is negative, we have to move to our left because it is negative. So moving to my left from the decimal point is going to give me 1, 2, 3. 3 times. So the decimal point here has moved to this position. Because there are no numbers here, we are going to replace them with zeros. So I'm now having 0.00632. Because there is no number in front of the point, you can't leave it like that. So we just bring 0 in front of it. So this into its original number is going to give us this. I hope we are okay with it. Go. The same thing we are going to do here. The power is negative 6. So you are moving to your left 6 times. So I'm going to get let's move to this side. 2.56. This. 2.56 times 10 raised to the power negative 6. We are changing this number into its original number, but we have to consider the power of 10. Because it is negative, the movement will be done to the left. How many times? 6 times. So let's move. 1, 2, 3, 4, 5, 6. The decimal point has moved to this direction. So now, since there are no numbers here, replace them with zeros, 0, 0. So the decimal point is now here. 0, 0, 0, 0, 0. 1, 2, 3, 4, 5. Then 2, 5, 6, 0. So this into its original number is 0.00000256. And this is how we change numbers in standard form into its original number or its original form. Let's look at the next one. Addition and subtraction of numbers in standard form. When it comes to the addition and subtraction of numbers in standard form, we use the idea of additions in decimal fraction. And in our previous video, we talked about how to put or subtract decimals. But because it is in standard form, you can only perform the addition straightforward if the powers of 10 are the same. So if you look at this one, we are having 2.145 times 10 raised to the power 4 plus 1.14 times 10 raised to the power 4. When you are adding in standard form, check the powers of 10 if they are the same. If you look at the power of 10 here, we are having 4. The power of 10 here, we are having 4. With this one too, we are having 4. Because the powers of 10 are the same, we are just going to put the decimals or the numbers together. So I'm going to put 2.145 plus 1.14 together. No number, so 0. And we've also talked about how to add decimals. So adding or putting this together will give me 582.3. This is going to be my answer. So since they are all having the same powers of 10, my answer is going to be 3.285 times 10 raised to the power 4. I did it this way because the powers of 10 are the same. So since they are the same, I'll just add the decimals. And we write it down as simple as it is on the board. So if the powers of 10 are the same, just put the decimals together. Then you go. Let's look at number 2. We have 5.48 times 10 raised to the power 3 plus 2.52 times 10 raised to the power negative 3. When you look at the power of 10, this is having negative 3. This is also having negative 3. Negative 3, they are the same. So with this question too, the powers of 10 are the same. So because the powers of 10 are the same, what do? Put the two decimals together. So let's put the two decimals together and see what we are going to get. So we have 5.48 plus 2.52. So let's do the addition and see. 8 plus 2 is going to give us 10. So we are going to record 0, remainder 1. 4 plus 5 is going to give us 9. Plus the remainder will give us 10. So 0 point remainder 1. Then you put this together. 5 plus 2 is 7. Plus 1 is going to give me 8. So putting this together, I had 8.00. But note that if in case you add and the number here cannot be found within the ranges 1 to 9, just as we said, then you have to change your answer into standard form. So let's assume that after changing this one, adding, you had 12 points. The 12 is not in standard form, so what do? You change it back into standard form. Then you add the powers to get your answer. So putting this and this together gave me this. So because the powers are the same, my final answer becomes 8.0 times 10 raised to the power negative 3. Because the powers are the same. So you just go straight forward and you perform the operation. One may ask, what will you do if the powers are not the same? Just like the remaining questions. If the powers are not the same, okay, so with the number 7, good. The powers are the same here. So we are having negative 7, negative 7. The powers of 10 are the same. So let's say here we are having, let's say here we have 9.122 minus this. So the powers of 10 are the same. So because the powers of 10 are the same, we will just go straight forward to subtract this one. So this one is for the subtraction. So 1.14. So what are we doing? We are subtracting. So we subtract. No number here, so we bring 0. 2 minus 0 is 2. 2 minus 4 is not possible, so we borrow. Okay, so let's maintain the number that it was. Let's maintain it. So 2 here, 2 here. Good. Let's maintain the number. So let's go back here. Let's go back. Good. So we are having 2.122 times 10 raised to the power negative 7 minus 1.14 times 10 raised to the power negative 7. So because the powers of 10 are the same, we can therefore just subtract these ones. So we have 2.122 minus 1.14 1, 4. So there's no number here, we bring 0. 2 minus 2 is 2 minus 0 is 2. 2 minus 4 is not possible. So we are going to borrow from our neighbor. So if we borrow, this becomes 0. This becomes 12. So now 12 minus 4 is going to give us 8. Now the number here is 0 and not 1 because we've borrowed 1. So I'll come and borrow again from my neighbor and this will become 10. So 10 minus 1 is going to give me 9. 1 minus 0 is possible, but I'll get 0. So when you look at the answer for this one, we had 0.982. Now with this number, we can't write times 10 raised to the power negative 7. Why? Because this number is not in a standard form. 0 is not within the ranges we were given. We said in standard form, the numbers are ranged from 1 to 9 or between 1 and 10. So I have to change this number into standard form. And we talked about how to do the changing of numbers in standard form. So I'm going to move to this direction 1. So this in standard form is giving me 9.82 times 10 raised to the power negative 1. So it is this number that I changed into standard form, but it was in this standard form as times 10 raised to the power negative 7. So with this, we are going to apply the laws of indices that we were taught in the previous video and in classroom. The first law says that if the base are the same, add the powers. So we are going to add negative 1 to negative 7, and that is going to give us negative 8. So in standard form, the answer for this is going to be 9.82 times 10 raised to the power negative 8. We change this one into standard form because our answer was not in standard form. So changing this into standard form gave us 9.82 times 10 raised to the power negative 1. But the subtraction was done based on 10 raised to the power negative 7. So we have to multiply this to get our answer. Now what will you do if the powers of 10 are not the same? If the powers of 10 are not is that change each number into its original number, perform the operation, and change it back into standard form. So I'll change this number into its original. So this into its original, I'm going to get power is positive. And we were told that if the power of 10 is positive, move to your right. So I'm going to move 1, 2, 3, 4, 5. 5 times. No number, 0, no number, 0, no number, 0. So with this number, I'm having 246,000. Then I'll change this number also to its original number. I'm doing this because the powers of 10 are not the same. So this 2 is going to give me 1.54. It is having a power of positive 3. If it is positive, move to your right. How many times? 3 times. So 1, 2, 3. There is no number here, so I'll bring 0. So this number, which is this, is 0, 4, 5, 1. Then what are we doing? We are adding. You put them together. So this plus this is 0. This plus this is 4. This plus this is 5. This will give me 7. 4 and 2. So putting this and this together is going to give me this. So the answer that we have here we are going to change this answer back into standard form. So changing this into standard form will give us, starting from here, because it's a whole number. 1, 2, 3, 4, 5. So in standard form, we are going to get 2.4754 times 10 raised to the power, we moved 5 times. I didn't bring the 0 because it is the same thing. But the number of times that we moved matters. So we moved 1, 2, 3, 4, 5. Because we moved to our left, the power becomes positive. That is, if you are changing the number into standard form. With the subtraction to the same thing. If the powers are not the same, change the number into its original. So changing this one into its original, I think this will not go there. Into its original, we are going to have 4.33. We have been able to get the answer. Thank you very much for staying tuned. God bless you. So we have been able to look at how to change numbers into standard form and how to change standard form into its original number. And we've looked at the addition and subtraction. See you, God willing, next week, while we look at the multiplication and division of numbers in standard form. Bye-bye.